So before I deal with this problem here, I want to review a couple of rules of significant digits. First off is that these leading zeros, these are placeholders only. They do not count as significant. So in this problem, the 3 is significant. Over here, again, that 0 is not significant. This 1, and this 8 are. So this has 3 sig figs, and this has 1 sig fig. Again, leading zeros, not significant. Now, if I'd written this, let's choose an easier one. If I'd written that 0.014 as 0.01400, now I have 4 sig figs because they're trailing. And this becomes kind of perplexing to students because they want to hold on to those zeros as being significant. And this is the easiest explanation I can give you. In the work that I do, everything is on the order of like 6.1 times 10 to the negative 10. Ideal in angstroms. It wouldn't make any sense for me to measure anything earlier than this. So in other words, 1, 2, 3, 4, 5, 6, 7, 8, 9, oops, yeah, 9, 10, 1 is what I'm actually dealing with. I don't know what these numbers are. These just hold the place for me to get to the thing that I'm measuring on such a small scale anyhow. What would become more, or what would increase the number of sig figs in this particular number would be if my instrumentation was more precise. And if it were, then I wouldn't end up with more digits here, I would end up with more digits here. More precise means I'm extending the amount that I can measure, so it would be something like 6.123 times 10 to the negative 10. So notice I'm still moving, those zeros are still existing there, but now I've said, okay, my instrumentation is really good, so I know that I have measured even smaller than 6 angstroms, and I'm confident of that. And in a laboratory, this 3 would represent the point where I'm uncertain. That's where I'm making some sort of approximation. And I'm telling the scientific world that I'm absolutely confident of these numbers, that my equipment can generate this sort of precision. I'm approximating here, but I know these guys. And that becomes the importance of relating significant digits to people in science. Okay, so these zeros don't count, but a 0 after the decimal would. If I had the number 423, oops, 423, that has 3 sig figs. If I have 400 or 4,230, that still only has 3 sig figs. Unless I put in a decimal. Now I'm saying that 0 actually counts. It's not a placeholder anymore. If I added another 0 here, now this 0 is sandwiched between this 0 and this 0 after the decimal says that that is a significant figure. So now I have 2, 4, 5. Cool. So that's the basic rule behind sig figs on how to count them. Now up here we have 2 different things that I put going on. I have addition on the top, I have subtraction, I have multiplication here and here, and then division for my 2 answers. So in lecture, what I was talking about is keeping track of how many significant digits you're generating here. So remember, addition and subtraction counts only on the number after the decimal. And hopefully that's starting to make some sense, or it will make more sense when we get into lab, because after the decimal tells us how precise our equipment is. The stuff before, we can get all sorts of big numbers, but out here is where the money really happens. So I have 3 here after the decimal, 4 after the decimal, 4 after the decimal. So I'm going to add these guys up and have an answer no bigger than 4 after the decimal. So let's see what I get from that. I get, this comes to 3.6308. Now mathematically, I'm going to hold on to this whole thing. I'm not going to do anything to it. So 3 after the decimal, but my sig figs are going to be cut here. So this whole chunk is giving me 1, 2, 3, 4 sig figs. So I'm 4 sig figs here. So again, I'm not going to do anything in my calculator. I'm not going to round that up. I'm going to leave it alone. And I'm going to multiply this whole thing times this 423. And I get 1,535.83. I bet. Yep, it's 8284 actually. 8284. Okay, so now let's look at our sig figs between these two numbers. I had 4 here, and I have 3 here. So my answer up top can't be any more than 3. So top is going to be 3 sig figs. And I'm leaving that number alone until I'm totally done. Now let's come down and see what the bottom is. So subtracting the 2, the number after the decimal is what counts. So this 3 numbers after the decimal, and 1, 2, 3, 4, 5, 6, so 3 is going to win. This is going to be the limiting factor, so I'm going to have 3 sig figs here from this answer. And over here, I have 4 sig figs. So the smallest amount of sig figs wins. So 3 sig figs is all I'm going to be able to carry from here. So it turns out, no matter what, our answer is going to have 3 sig figs, because top and bottom have 3. So this number ends up becoming 0.01374, and this, well, is obviously 7362, so this is 101.183. Notice I did not change these numbers. I did not round them in the intermediate steps. I merely kept track of how many sig figs I'm going to get from each piece. This I wrote out just so you can see how the adding impacts our sig figs here, not because I'm rounding it. So now the final answer here then is 101. Make sure you can see that, 101.183. So we've decided that the most it can have is 3 significant digits, so my final answer would be reported as 101. Everything else goes away. So that has 3 sig figs. There you go. Addition, subtraction, it is the number of decimals, number of places after the decimal that are the limiting factor. The one with the fewest is the one that determines the addition, or sig figs for addition and subtraction. Multiplication and division, it's the fewest number of sig figs that are being used. That determines the number of sig figs that you get. So here it's going to be the fewest number used. They both equal each other. We have an answer of 101. And that is sig figs in a nutshell.